Okay, everybody back from lunch? Well, not really. Okay. This next presenter, I got to tell you, is somebody I really admire a lot, and his name is George Wiseman, and years ago, he went through a lot of what we're all going through now, doing experiments and tinkering around, and he decided he was just going to take a chance. So he started doing experiments and making books and manuals and selling those books and manuals. And it seems to have taken off for him. He's selling Brown's gas generators now. They've made some really nice units. And I really like that attitude about, you say you can do something, and then you sell plans that work, not plans that are fake, time travel and anti-gravity and free energy. Well, yeah, if you buy those plans, then they work. Why aren't we up to our neck in free energy, anti-gravity, and time travel? So that tells you right there that the plans are probably bogus. You won't see that on George's side yet, right, George? So you're working on it. Anyway, this is George Wiseman. He came a long way to come here, and please give him a good round of applause.
Okay, thank you. Jerry Decker's been an inspiration, a catalyst for a lot of this stuff. There's been times in the past when Stephen Ellswick over here was working with the Tesla Society, and he's still doing some good work with the exotic research. Different people have put together presentations like this one. I'm proud to be here, pleased to be here. Yeah, I see a lot of faces that I've seen before at other places and a few new people. It's good to be back. It's good to be able to show this kind of thing. And as an inventor who started quite young, you'll see some of the things as we're going. It's nice to be able to come up here at this particular time and be able to show the kind of things that have been happening. So we'll get this started. I'm first going to show a little bit on the applications, marketing, that sort of thing of Brown's gas. Just to show how many people in here know what Brown's gas is. Okay, only about half the audience. Okay, it's going to be a little harder than I thought. Because I was assuming that I was coming to an educated audience. So the people that do know, just bear with me a little bit as I explain a couple of the details from time to time, and then we'll show some of the other things that Brown's gas can do. What's happened is we've gone beyond just experimenting. We've actually made machines. We're now in the marketing of these machines on a worldwide basis and that kind of thing. So tomorrow you'll actually see more of what the Brown's gas can do in video and a little tabletop experimental machine. But today I'm going to show what some of the potential of Brown's gas and what it can do. I'm going to have to go through this relatively quickly. We're already a little late, and this is a one-day presentation being squished down into an hour. So, click. Be sure to write down any questions. I can't really take them as I go, and I'll try to have a question time at the end. Click. An idea whose time has come. Click. That's me. I was doing some consultation where they wanted to look at the bottom of a lake several hundred feet down and find a great big gold nugget. I helped them get the equipment that would look there and find it, but there wasn't anything there. Click. It was a lot of fun, though. I'm a dreamer, just like Peter Lindemann and Doug and a lot of other people that you've seen. We're the people that see it before. We're trying to show you our vision transference, and we go from there. Click, please. At this point, we're going to show a videotape, the part A, that gives a bit of a history on Brown's gas, so that you get a bit of an idea. Now, what Brown's gas is, while the tape is starting to run, is a mixture of hydrogen and oxygen and water vapor coming out of specific kinds of electrolyzers. When you split the water at exactly the time and then use it within a few minutes, well, you just split it together. You can actually use it a year later, but the sooner you use it, the more power you get out of it. You can get effects by doing this that you cannot get by just using hydrogen and oxygen in bottled form. And by doing this, anytime you want to play the video, just go for it. So what we're doing is Brown's gas is a mixture of about 6 different gases. This is William Rhodes, who was the original inventor of what they call the dual-ducted gas. He's 86 years old today, still bright, incredible mind. This is some of the patents that he has patented in his life. It's interesting that he invented and had you'll see the pictures of his device and stuff. It's interesting that his research was virtually identical to mine, or mine was identical to his, being as I did it as, but he did this 35 years ago. And when so this is his patent for the dual ducted machine, which shows a series of plates. You'll see more of that tomorrow. And you'll see a picture of the actual machine in a second. The company he started and the people that he was working with essentially screwed him, and he quit working with them and went on with other patents. He's been national security advisor, all different kinds. Anytime the government needs help, he's one of the people they call. And when I compared my notes to his, they were virtually identical. And he allowed me to actually copy his entire note file for my files. And Yul Brown, this is Yul Brown here at his shop in laboratory. Now what he was trying to do is make vehicles run on water, and what you're seeing is a dyno set up here with an engine and a propane type carburetor converted to hydrogen, and then back behind here you see the electrolyzer, which was 10,000 liter an hour electrolyzer based on the old technology, not the new stuff that we've got. And when this 10,000 liter an hour electrolyzer turned on, it dimmed the lights in the neighborhood. But it did run this engine. It produced enough gas to run this engine. Now the technologies that you're hearing today actually would be able to produce the same volumes of gas, but using relatively small amounts of electricity, so an ordinary alternator can actually produce enough gas by splitting water to run an engine. But that's future stuff. I'm not like some that'll tell you it exists now. I'm saying the potential exists now. We can run engines on this gas. We just have to find a way of producing a large volume of gas with a small amount of electricity. And that has happened many times in the past, twice in my own shop, and I have documentation on quite a bit of other people who have done it around the world. This is Yul Brown in his factory. I apologize right now for the poor quality of the video. This is not poor quality shooting right now. This is historical coverage of tape, and that's the best I've got, and it can never be repeated. But this is Yul Brown walking around. That was putting about 200 units a month, as I understand, in that particular factory. This is a series or a medley of various machines. That's green gas. The factories they're making the machines in, Brown's gas machines. Green gas is a definite contender in the Brown's gas field. The fellow who did the Brown's gas green gas actually worked with Yul Brown in Australia. Then he went off to another country and started making his own machines, calling them green gas instead of brown gas, because he didn't want to have a conflict there. This is one of the original, like the alpha version of the Brown's gas, Yul Brown's machines that came from Australia, and it's being demonstrated here in California by David Ennis of Southwest Concrete. And David at this point is doing a documentary for television and showing the various effects that Brown's gas can have. And here we go. These people are speaking Japanese or Chinese, I forget, and I don't know why there's such big gaps. Okay, here we go again. This is best Korean. They're speaking Korean. He said, "Oh, this is water," and they put the water in the machine, and then they have the flame going like this. Very dramatic. And so this is best Korea, which is another offshoot of Yul Brown's technology. Yul Brown sparked, and that's why I call it Brown's gas, even though William Rhodes was the originator of the gas. Yul Brown really is the one that made the gas commercial. Unfortunately, all these machines are using obsolete technology, and not as good a technology as we have on the market, and certainly not as good a technology as we have in the industry, that we have in our own labs now. And with this new generation of machines that are coming from Peter Lindemann stuff, and Doug and all these other, John Bedini, all these other kinds of things where we can produce a lot more gas with a lot less electricity, we can do a lot more with Brown's gas. This is Yul Brown with a bunch of machines that are going to be sold to Dennis Lee. And you'll see Dennis Lee in a minute. He had repainted the machines, so that instead of this color, they're a blue color. And Dennis Lee I'm going to say acquired the rights to sell the BN, which are China version Brown's gas machines, in the United States and bypassed Yule Brown entirely, even though Yule Brown is the one who helped the Chinese build these machines, design and build them. And Yule Brown went back to Australia and died penniless, and Dennis Lee is still selling these machines in the United States. Now these machines are producing gas at somewhere around, this is Dennis Lee with the blue machines you see in the background. These machines are producing a gas at about almost 6 kilowatt hours per liter, and you see the size of the machine back there. That's about a 1,000-liter machine, 1,000 liters an hour. Our machines are quite a bit smaller. You'll see in future videotape. Okay, that's it for the video there. And we'll go back to the presentation. And while it's being switched back to the presentation, so Brown's gas is a mixture of hydrogen and oxygen. You take water, which has 2 hydrogens and an oxygen, 2 hydrogen atoms and an oxygen atom, and you split it apart. You have monatomic gases. That there is some monatomic gas in the mixture of Brown's gas. It's one of the things that gives it its most power and its implosive characteristics. However, most of it is still diatomic. You can start anytime you want. Still diatomic hydrogen and oxygen. Go ahead and click it. So it's an explosive mixture. And I'll be back to that a little bit later. I just talk about that in the transition times. Okay, where's the market for Brown's gas? I mean, why would anybody want to buy it? Click. There's the industries that need Brown's gas. Click. And as this is continuing, there's an incredible amount of potentials. For example, I'll just tell a story of a power plant. Right now, what they do is they produce a tornado of coal dust and burn that tornado in order to make the heat. And they use propane-fired jets to keep the tornado burning. Well, here what they can do is, because they have water already, because all power plants are located near a heat sink of water, they have water, they have electricity, so they can make Brown's gas, so they no longer have to use the propane. The Brown's gas also ignites the coal much more efficiently than the propane does, and produces a more efficient combustion altogether. So what happens is they can simply not use propane anymore. They can just ignite the coal with the Brown's gas and keep the flame, the vortex, going with the Brown's gas. It's just one application, which will save millions of dollars. We're only going after one application. I'll show more applications later in a presentation. We're going after cutting of steel, iron, thick iron. We've actually started a business on that, and I'll tell you a little bit more about it tomorrow. There's over $1 trillion worth of cutting gas sales each year worldwide. So this is just one application, one of dozens of applications where Brown's gas seriously competes with what's out in the industry already. And that's what you have to do, of course, is find where the competition, where a new tool can fit. Click. Brown's gas has a lower cost cut per inch and has a higher quality cut than most other gases. You'll see that tomorrow with the samples that I've brought. There are over 30 billion cubic feet of hydrogen sold just in North America a year, but it's mostly formed by reformation of fossil fuels like hydrocarbons. Hydrogen is not generally used as a cutting gas because of several problems which we've completely solved with our machines, and has a unique characteristic of producing a perfect mixture of hydrogen and oxygen without any valving or anything like that. It's just very simple machines. So what we're doing is we're going after large metal fabricators, which include primary metal industries, fabricated metal equipment, industrial and commercial machinery, transportation equipment. And just for one simple little thing, there's over 8,000 bridges in New York State alone that have been announced to be in need of repair. Brown's gas cuts rusty metal fast and clean. In fact, the government is mandating, the United States government is mandating alternatives to carbon-based fuels in places like, I had some people approach me about cutting up an old prison. And inside the building, they didn't want any carbon monoxide being formed and that kind of thing, so they had to use hydrogen and oxygen gas to cut apart all the steel and everything inside the prison. Brown's gas cuts are rust resistant. You'll see some samples on that tomorrow. Industry problems that Brown's gas can solve. High cost of fuel gases. In my shop, I can produce $50 worth of cutting gas for 65 cents. And that's paying commercial prices at the grocery store for the water. Brown's gas is a fraction of the cost. Okay, so high cost of consumables. When you are working with plasma arc, for example, you don't pay so much in a fuel gas, but you end up paying in electrical and in the tips. In order to maintain a good cut, you have to keep replacing the tips because that plasma just vaporizes them. There are no consumable costs with Brown's gas. I've used the same cutting tip for 4 years without even cleaning it. The quality of cut is absolutely superior, particularly when it's on a cutting machine because it can hold it steady. The cut is so laser-like that if you make any wiggle, you'll see the wiggle. It's a relatively cold flame, so it doesn't melt off the edges like acetylene does. You'll see more of that tomorrow in the video. You don't have to dress it before welding it. The oxidation layer on the cut is very thin, so you can actually just weld the metal after you've cut it without having to grind off the oxidation layer. In machining, again, the cuts are so straight and smooth that you don't need to do any additional machining in most cases. It's going to save people a heck of a lot of money and time. And heating, you only have 20% of the heat hardening that you do with a hot flame. So again, if you're machining a piece of metal, if you do want to machine it, you don't have to dress it. You don't have to cut off the heat hardened zone. You can just start heating it, cutting in the lathe right away. The exhaust from Brown's gas is just pure water, nothing else. So, and when you have additional other technologies, like if you change from acetylene to MAP gas, for example, in a torch cutting machine, you have to change the hoses because the gas is incompatible with the MAP gas is incompatible with the acetylene hoses. The Brown's gas is actually plug-in and compatible with all hoses in industry. The competition. Now we're talking competition of other various kinds of things. So we have existing infrastructure. In other words, they're already in place. Brown's gas is not. They have qualified technicians to fix everything. They have fast cuts in thin metal. They cut all metals and all materials, in fact, depending on what kind of competition you're looking at. Now we're talking about plasma arc and abrasive water jet and all those kind of things in cutting. Now remember, we're just going after one application here. There's no way I have hours, days enough to tell you about all the advantages Brown's gas has in all the other applications. Okay, here's disadvantages of Brown's gas and what we've been doing. We have a disadvantage because we need to integrate with existing technology, but we design machines that simply plug in. You simply take the hose off from the bottled gas and plug in the Brown's gas hose. Portability has been a problem because you could just take bottles anywhere. Well, what we do is we design generator-compatible machines, relatively light, to generate a lot of gas with a little amount of electricity. Consumer education. Who the heck knows about Brown's gas and why would they even want it? And that's what we do is we write and distribute literature which you can buy. I'll have brochures later. Lack of technical expertise. Who the heck knows how to work with it? And again, it comes down to developing training and literature. The Brown's gas is explosive. It's only under certain very exact conditions that you can get an implosion. So we have to design machines with redundant safeties. My machines are actually simpler and easier to operate, safer to operate than using oxyacetylene mixtures. Brown's gas can't be stored for that very reason. If you put Brown's gas under pressure, you have yourself a heck of a bomb. And so we simply generate the gas on demand. There's no storage, and therefore it's actually been approved in places where bottled gas is illegal, where you need to be down in a mine site that has combustibles all around it. They're not allowed to have bottled gases, but they can have these machines. They're approved for that sort of thing. Brown's gas, generally speaking, required large amounts of electricity to produce. We've made super efficient machines, which are going to be like ultra efficient here pretty soon. Brown's gas machines are expensive to build. Well, we've solved that in our marketing plan, which you'll have access to. Our next marketing meeting is in November, and I'll tell you more about that tomorrow. Brown's gas advantages. The flame does not need atmospheric oxygen. The gas can be created on demand. It's environmentally compatible. The gas is lighter than air, so therefore if you're in an enclosed area, if you have any kind of ventilation whatsoever, it goes. It doesn't build up explosive mixtures. I was actually at a mine where they had underneath a acetylene pond a propane explosion that took out 2 people. That would never happen with Brown's gas. The hydrogen diffuses in air faster than any other gas known, and besides the ether, but we won't get into that. What happens is if they did a study, the government did a study, United States government, where they split open a tanker car, a truck, on-road highway truck, just to see what the potential would be for explosion damage. In 2.5 minutes, there was no longer a combustible mixture in the area. We're talking liquid hydrogen, a full truck full of liquid hydrogen. In 2.5 minutes was gone. Of course, it was very cold. Okay. Brown's gas is extremely efficient preheating when you're preheating anything. Extremely controllable flame, very laser-like. In fact, you have to do things if you want to have the heat spread out to make the heat spread out. It has a low radiant heat. I'll show you some samples tomorrow that show how little the radiant heat is of the flame. It has no fuel gas bottles, and it has faster cuts in thick iron. The radical new oxygen actually assists the cutting process. So again, instead of having bottled hydrogen and oxygen, you can have this gas cutting steel faster, 25% faster than you can with just bottled hydrogen and oxygen even, which cuts only at about the same rate as acetylene. Okay, the competition for electrolyzers out there. There's Aqua Gas. In New Zealand, they are an offshoot of Yule Brown. They're repairing old machines. Arizona Hydrogen is the company that eventually developed into from William Rhodes' original patents, but they're not using the series cell design. And they make very nice traditional micro machines. There's Best Korea. You saw some video of them. They have a limited manufacturer. The Can Rapid up in Lacombe, Alberta, has a prototype. Green Gas, I'd say there's serious competition out in the world. They've put a 40,000 liter an hour electrolyzer in a shipyard in Yugoslavia, I believe it is. And they're manufacturing Brown's gas machines. H2O 2000 in Florida has a prototype and is looking to go onto the market. The Infinite Energy Corporation in Toronto has a prototype, nice machine, but it just is it has problems. Norinco is the China version that Yule Brown is selling, Dennis Lee is selling, manufacturing Brown's gas machines. Spirig has been making small machines. They're very expensive in Switzerland for almost, at least 15 years. Sustainable Development International is, I wouldn't want anything to do with them. They're selling for about 2 cents a share on the stock market at this time. And there's things with the company I just won't bother to explain right now. Water Fuel is another company that has a prototype. And Yuchang, I think they've pretty well gone out of business at this particular point. Here is a lot of the other applications. Now, we were just talking about cutting of steel. These are applications of the Brown's gas. It just goes on and on. We'll talk about a couple of these applications in a second here. Understand that I've been whipping through this program so that we can have a little bit of time for things. Okay, now we'll start part B of the video. So Brown's gas is actually a mixture of about 6 different gases, all created from water, all created on demand as it's going. It's got the monatomic oxygen and hydrogen, it's got the diatomic oxygen and hydrogen, it's got water vapor, and it's got a mixture, something that I call expanded water, where the water didn't actually split, but it gained so much energy that it turned into a gas without actually being steam. Okay, so you have a water vapor which is electrically enhanced instead of steam. And with these 6 different gases coming out, you get effects that you just can't get with any other gas in the world. You can start the video anytime. This is where we... Uh-oh. Did it go too far? Or not far enough? Okay, we actually needed to... I don't understand. Excuse me while I'm being confused here. That should have started. That started right from the same place, didn't it? Or had that video been running all that time? It was 3 seconds. Okay. Well, I'm not sure exactly what happened, but a bunch of the video just got, I don't know where it went. Maybe it's on the other videotape. What you're seeing, what you saw first there was the ending of the building of the beta version ER 1150 water torches. And now you're seeing the building of the ER 4000 that we sent to Louisiana. This is Hall effect amperage limiting, which we're using in this case instead of the capacitive amperage limiting. And it does a wonderful job of holding the amperage right on the money. This is Art Davis putting the machine together. And inside there, you just have a series of a ring and a plate, a ring and a plate, a ring and a plate from one end to the other. High tech. Plunger there, you see. Yeah, that's right. It works. It works very well. He's got a little level on the top of it, that, or at least he put one on it later so that you can see get every plate exactly level. And so you just have a series of plates in there. This is showing the various components as they were being built in our laboratory there and just outside the door. This is actually in Creston, British Columbia. The video that and this is my prototyping lab. In the video before, it showed where we were building them in Missoula, Montana. And this goes through and shows the development stages as we were putting the machine together. Liquid vapor separator. We're talking a very extremely simple machine. The commercial versions are just simply enhanced versions of what you're seeing right here. They have the automatic water fill and low pressure shutoffs, and it's a 9-point shutdown system. This is Mark Hetrick, who has done a lot of good work with Brown's Gas over on the coast. Following my work, actually building machines better than that look better than mine. He's a machinist and millwright, and does a lot of good work. He duplicated virtually everything that I have. Every time I write a book, Mark Hetrick duplicates it, brings out all the fuel savers, shows me on his Nova. He's got a Nova he drives around, and it's got everything on it. And then as I moved into Brown's Gas, he started building those machines. So this machine, the electronics are coming on. That's the electronic relay, and then the full wave bridge rectifier. So it's a 3-phase machine if you want to be it single phase, double phase, 3-phase. It doesn't matter. And these machines are made to operate on a voltage, like for example the ER 1150 can operate from 160 volts to 270 volts and anywhere from 40 hertz to 70 hertz. It just doesn't care. That's the simplicity of the kind of power supplies that we're building. And we've discovered the same sort of thing that Peter Linden was talking about before, is that you hit the electrolyzer with a jolt of electricity and then back off. So it's pulsing, always pulsing. And the harder you can hit it, the more gas you get for the same amount of electricity. For example, our machines, like this one, are generating gas at somewhere around, the commercial machines are about 3 kilowatt hours per liter, whereas the ones you saw with Dennis Lee are almost 6 kilowatt hours per liter. These particular machines that we have now can actually produce gas at about 2 kilowatt hours per liter, which means it's actually producing gas using less electricity than you get back from the gas when you burn the gas. Thank you. They figured the theoretical efficiency to be straight DC at about 1.23 volts per cell, and a certain amount of amperage produces a certain amount of gas, and these machines do a better job than that. So this was just about finished on this particular piece of video now, and since if I get a chance, I'll show you that other video tomorrow. It's on those tapes. I just obviously started in the wrong place. Okay. Now, are you going to be able to? Yeah, go ahead and click to the next screen there. So Brown's gas is a mixture of these various gases that are extremely useful in their application. It defies the known technology of electrolysis in that it produces a gas with so little amount of power. Now we'll show. Okay. Go ahead. This is other potential uses. And I'm just wondering, since it's so difficult to switch back and forth between the video and the screen, what I'm going to do is, we've got this quartz ware manufacturing. I'll go to the next screen. Go ahead to the next screen. And we'll say other potential uses, and then click and click, 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 and click. Okay, we'll just go down these a little bit, and then I'll show you some video coverage, and then we can have some question period. First, the quartz. You'll see some video coverage of the quartz manufacturer, essentially a Russian artist doing some quartz work. You saw in that picture that was right there a quartz snail with a real live snail right next to it. It's just a cute picture that I had. Vasily Trotsenko made that little quartz snail for my wife, and it just so happened that in a river nearby there were snails that looked exactly like it, so I put one next to it. And you'll see some video of him actually. You'll want to get the second video ready to go. The video of him actually making quartz art, and he makes some absolutely delicate, wonderful stuff. Trained in Russia, came over, is operating in Arizona, and says that Brown's gas is the absolutely perfect gas for making quartz art. So if an artist says so, there you go. If you're just making crockery and stuff, labware out of quartz, that's one thing. But when he's making this art and doing this absolutely delicate work and says it's the best, and he explains some of the reasons why it's the best, having to do with oxidation and what have you. So quartz manufacturing. Then we went on to, I needed my checklist here a little bit. You'll see some neutralization of radioactive waste. You'll actually see actual video of that happening in a second. The creation of semi-precious stones. You won't actually see that except right at the end. There's a thing with feldspar that has to do with it. What you're seeing with what happens with Brown's gas is when you cook ordinary rock, like feldspar or quartz, it actually turns into a stone with a hardness of about 9.5. It actually changes the structure of the material. So you have something that's almost as hard as diamonds. And because you can do this with feldspar, which is probably the second largest, besides aluminum, component of the Earth's crust, after aluminum kind of thing, you can actually make a transparent, and I'll show you some samples tomorrow, transparent ceramic, which is stronger than steel and never corrodes. And the thing that has been holding up this sort of thing it has been just simply a source to work this stuff. And if any of you get Popular Science, and has for a while, a couple of years ago they actually had on the front cover a bridge that kind of looked like the Golden Gate Bridge that was made out of feldspar. Okay, it was just an artist's conception, but you have virtually transparent bridge with this completely made out of this transparent ceramic. And the only thing that prevents bridges like that from being made today, because billions of tons of this feldspar are already available, is the amount of gas it takes. In this case, this gas works this stuff really well, the amount of electricity it takes to make enough gas to work with it. And if a person has that amount of electricity, then you can even make boring machines that can go right into mountains and just make tunnels just right into the mountain. Just gas just melts the rock right ahead of it. The next thing up there is ore and mineral separation, as we're talking about that same kind of thing. When you're vaporizing this rock, you can actually distill the rock, and so you get the iron and the copper and the gold out just like fractional distillation process. Totally environmentally compatible. No settling ponds, no chemicals, no flotation tanks, none of that stuff. The next thing is healing arts applications. We actually have several different ways. Brown's gas is a breathable gas in its pure form. You don't want to smoke while you're breathing it. But underwater, the Navy has tested for several days people breathing this gas. And the thing with the hydrogen is that it goes into and goes out of the blood a lot faster than even helium. Anybody that knows anything about diving, generally speaking, they replace an oxygen nitrogen mixture with oxygen helium, but when they want to go down at deeper depths, they replace it with oxyhydrogen. And they can stay down longer and come up faster if they're using this oxyhydrogen mixture that essentially is Brown's gas. So they can actually create the breathable mixture they need with the water a mile or two down, if they wish. All they need is the energy, the electricity to split the water. And then with the other healing arts, it turns out that if you put Brown's gas on your skin, the energy and perhaps some of the atoms go right in and do things. How many people here know of oxygen therapies? Various oxygen therapies. Okay, about half the audience. It turns out that one of the things, our body is 60% oxygen. So oxygen is a very important thing to us, and the way that our bodies deal with oxygen ends up being a problem. In some cases you get free radicals and what have you, but another thing is that we don't breathe enough oxygen, generally speaking. People that learn how to breathe better, which I don't, end up being a healthier person because you need the oxygen. Your body needs the oxygen for combustion, for energy. And so what happens is you'll get a muscle cramp, for example, and those muscles don't have enough oxygen. You put the Brown's gas on there, because there's this little suction cup kind of a thing, and it goes right in on those muscle groups and just relaxes them. It's almost amazing. We've had people with tennis elbow report in just a couple of minutes that the pain is gone. Stuff like that with oxygen therapies. So you can breathe it, you can apply it topically. There's a few other healing applications. For example, wounds heal a lot faster and cleaner if you apply the Brown's gas to the wound. Now all these things are being done by people who have told me not to mention their names because they're afraid of the medical society. That's before you light the flame, right? That's using the gas with no flame, that's right. Now there is some things if you want to use the actual flame. For example, I have some video coverage of Yoel Brown flashing the hair off of his arm because the gas, generally speaking, you can run your hand through it, and you'll see video coverage of that. And when you are in the process of running a flame over your arm, it won't burn the skin if you run it fairly quickly, but the hair just flashes into incandescence and disappears off your arm. So instead of having somebody like shaving your head, for example, you just go, poof, it's gone. But it makes a lot of stinky smoke in that particular kind of case, so it probably isn't going to catch on. Okay, we'll go on to the next one is new water. Norman Wooten actually was my first clue for this particular thing, and he happens to be here today. Hello, Norman. You saw him earlier. He showed me that him along with a fellow by the name of Joseph Bender, who's relatively local here as well, worked with, Joseph Bender was making new water, and he had several different ways of doing it, but Brown's gas is one of the ways. Because when you split the water into the hydrogen and oxygen and then reform it, it actually is what we call new water. Now this new water has characteristics totally unique. It turns out that, again, we're 60% oxygen. Most of that is water, in the form of water. Our bodies store some sort of energy in actual energy form, but also in information form in this water. Okay? Now, there was a study done. I'll get back to Joseph in a minute. There was a study done where they had a slaughterhouse, and they took control group of cattle and put them off to the side, and another control group of cattle, and fed them the water that came from the slaughterhouse. Now what they'd done is the control group of water, they just fed the control group of cattle, they just fed the water direct, and then they took the the same water that went through the slaughterhouse and purified it with every means that they knew. So essentially, chemically, it was exactly the same water, and then they fed this water to the second group of cattle. That group of cattle showed the same stress effects as the cattle that were in the slaughterhouse. Okay? Somehow the information, the stress, was stored in that water and survived the purification process of everything that modern technology knows, except things like this Brown's gas. Now what they do is when you split the water, if you reform the water in an environment, it soaks up the energy of that environment. So another study was where they took plants, and everybody here probably understands the classical thing where if you have classical music with a plant, it'll grow nicely, and if you have hard acid rock, it kind of grows scraggly. Anybody doesn't know that? Okay, well, no hands going up. Nobody wants to admit it. So what's happening in this particular case is they had plants off to the side, and they formed water in these two environments. They had classical music playing while they were forming this new water, and the way they formed it is simply they did the Brown's gas, and then when it was splitting back in a flame, because it goes back to water at that point, then as soon as it was water, it was new water, and it soaked up the ambience, this information that was around it at that time, and then they fed that water to a group of plants that was completely isolated, another complete area, and it grew just as if there was classical music playing in the background. And exactly the same with the acid rock, and another group of plants that grew just as scraggly as if there was hard rock playing in the background. So there's some sort of information that's being stored in this water. So the water is a very important thing that we're doing, and aside from cutting steel and what have you, this is an incredible applications that have to do with healing. Okay, we'll show this video now. I'm sorry that we missed that other little bit of video coverage. It's actually self-indulgent, if you will, but it showed the actual production of my Brown's gas machines from the very first one series cell I built right up until where the past video started, where the ER1150s were ready to go out to market. And the ones you saw there, the first one actually went to Australia, the second one went to England, and everything just spread around the world from that. You can start the video anytime. Okay, this is Vasily Trotsenko, actually doing making a little pear cactus, and doing a nice little job there. I have that particular cactus in my lab, and this is the Brown's gas from an ER1150 water torch in Arizona Hydrogen in Phoenix, Arizona. And there's holding Vasily's business card up to my camera. That's my thumb, by the way. Thank you. And there's Vasily.
So he was working on quartz?
Yes, he was working on quartz. He's a quartz artist, and an extremely exceptional one. Now, this is the ER1150 water torch actually operating, and Vasily making another pear cactus while I'm actually doing a presentation on Brown's gas. I'm forgetting exactly this moment which one that was. There's been a few now. So he's having a lot of fun just making that, showing that it works quartz just like propane works glass. And you don't see any of the oxidation effects that ordinary bottled hydrogen and oxygen tend to have on the quartz. The quartz stays absolutely pure and clean. These are the kind of things that he was pointing out. Just a simple working with the quartz. Now, I figured, I did a calculation. As far as quartz work goes, there's a company in Colorado that makes quartzware, and they spend about $100,000 a month on liquid oxygen and hydrogen. Okay? This can cut their, and considering all the electrical costs and everything, cut their entire budget by 75%. They can save $75,000 a month by using Brown's gas instead of the liquid hydrogen or oxygen. And then there's no more of the liquid oxygen and hydrogen on the highways, which has been fairly good. The United States has been not too bad with accidents on this sort of thing. But if it doesn't even exist on the highways to begin with, well, you'll have that much less chance of an accident. My father always saying, if you don't want something to fall down, you set it down. And it follows that if you don't want to have an accident, then don't create the conditions for an accident. This is David Ennis, again at Southwest Concrete in California. And what he's doing is heating up a piece of iron, just a piece of iron rebar, of which he'll add a little bit of aluminum to, that actually makes thermite. And this explosion, the little pop that you're going to see here, actually is one of the three procedures that neutralizes radioactive waste. Okay, now he's letting it cool now a little bit. He was just talking while he did that. There wasn't any other reason for it. He just wanted to have this pop happen when he was ready to. So now he's just feeding in a little bit of aluminum rod, no flux, and pop, just like that. And radioactive waste goes like a 96% reduction in radioactivity that fast. It also uses, like we're saying, at relatively low cost. So the trillions of dollars worth of cleanup of radioactive waste that are around in nuclear power plants and spent or outdated nuclear weapons can totally be neutralized at the source, right where it sits. It doesn't have to be transported anywhere. Virtually all these places they can have iron and aluminum trucked into them, and they have electricity already. They can just make the Brown's gas right there and neutralize it. So here's Joel Brown. He happened to have a slag pile of iron there, so he started adding a lot of aluminum, and he's got quite a bit more there than David Ennis did, so you're going to see a much bigger flash. actually burns holes in his shirt. He had a brand new white shirt there during that particular demonstration, and everybody was laughing, of course, after they got over the shock of the bang. But again, it's the same exact reaction. Aluminum and iron make thermite, and in this particular process, you add the nuclear material right into the mass there. Now, he doesn't at this point. We're just showing the reaction, and then it goes bang. It doesn't actually make a thermite explosion like if you had thermite, but it still pops and spreads some sparks around. Now, later you'll see the demonstration of the. Do we actually have audio capability back there of this? Okay. Yeah, wasn't that impressive? And then he just burned some holes in his shirt. But the next particular scene, I actually would like to have the audio for it, and it looks like it's going to happen because they explain it really well. This is a Canadian, Mark Peringa at Chalk River. Chalk River Nuclear Research Reactor is the largest research reactor in the world, and Mark Peringa is the director of that reactor. And he's, this is him here.
What I'm going to be showing you here today, I have a small, what we call scheduled quantity of americium-241 mounted on a small ferrous target material. It's actually plated onto that. And we've checked this. We've got roughly 100,000 counts per minute. Combination of alpha and low energy gamma. And what I'm going to be doing is I'm going to place this source on a piece of ceramic tile inside this fume hood. The idea of the fume hood is that I can confine all the gases, all the on-off gases, all the any dust particles that come off. If you look at the inside of this, I have a micronic filter paper element here to catch any of the gases, and also I'm taking the unnecessary precaution really just to make sure the material is exhausted to the outside. Again, this is a very small quantity of radioactive material. There's really no personal danger here. Turn it up to the highest scale.
So now we measure the radioactivity.
10,000.
He actually did this first with a.
So that's 100 times 1,000. That's 100,000 counts per minute. We're showing actually a little over 100,000 counts. We'll call it 100,000 counts on contact. And this is a low energy gamma and alpha source. So now we're gonna take this source. We're gonna put it in this little fume hood so that we capture as many of the gases and off products from the reaction. We just place it on a small piece of ceramic tile. We'll apply a little ventilation to our miniature fume hood. Basically, that's what we're doing.
Now, at the point that this happened, he had done this with 3 different Brown's gas machines.
Requires the ferrous metals substrate. Do that several times.
The first one was a Brown's gas machine he actually built using my Brown's gas book 2. He built his own Brown's gas machine and neutralized radioactive waste with a machine he built himself. So that was that reaction. I did fast forward it a little, but it was as fast as, or faster than the ones you saw previously.
I don't do it. If we break that up, we'll probably see about a 4-fold increase on the coming off here. But again, that's still well over a 90% reduction in the radioactivity.
So it's the same quality as the results on the smaller machine.
Yeah.
That's good.
Excellent.
Okay, we'll stop the video now. And we're approaching the time when it's time to stop. So what's happening is that just went on and showed the actual test results, and it was a 96% reduction in radioactivity of americanum. Virtually every radioactive material that's been applied to this gas, and I've got documentation on tests that were done in China and in the United States, even by the Department of Energy. This particular one was done unofficially by the Atomic Energy Canada via Mark Peringa, who is the head of the Chalk River nuclear reactor, which is Atomic Energy Canada's reactor. And they have since made a public documentation of this stuff that you've seen, and I've got that sort of literature for anyone who wants to. I'm selling it for a video and a relatively thick packet of information on neutralization of radioactive waste for $50. Just a copy of most of the stuff that I've got. In any case, Brown's gas has incredible applications, even more than you've seen here. We're currently starting a business which will go after just one of those applications, which is simply non-threatening cutting of steel. Like if you go into the politics of neutralization of radioactive waste, or running vehicles on water, or enhancing the medical community techniques, you're going to run up against political blockades that I don't want to bother with at this particular time, even though the technologies are perfectly valid for that. So what we'll do now is we'll have a very short question and answer period, and I'll see you back tomorrow for actual what Brown's gas can do. Any questions? How much what? How much does the machine cost? You can build a 3,000 liter an hour machine using my Brown's Gas Book 2 for a cash out of pocket of about $1,000 US. If you, that's right.
How many weeks of work?
I built my first one in 3 weeks of work. Yes. Is there a portable mic that we can have somebody go around and just make it a little easier?
Best if they come up here.
Okay, best if they go up there, because then they can take the video of the person as well. You'll be marked for life. Okay, so there's anybody wants to just line up at the mic and ask questions. If you want to buy a commercial machine, it's pricey. My ER1150s are going for $10,000 US retail. I sell them factory direct at $7,600 at this time, which is a couple of $100 more than the BN machines are going for. But since the machine is 3 times better, which you can see with brochures that I'll have here tomorrow, you get what you pay for. In fact, I refuse to sell a machine for less than Dennis Lee is selling for, because you do get what you pay for.
I have 2 questions, actually. The first one, would you make a relative comparison of the quality of cut with Brown's gas as compared, say, to flame cutting, plasma cutting, and laser cutting, with thickness of the cut width, and heat distortion zones, and fineness of the surface, and so forth, and thickness?
Okay, I have covered that a little bit, and your question covers way more time than we've got. I do have literature and I'm coming out with more literature, so if you just keep up with Eagle Research, you'll get that. Generally speaking, just focus on one thing. We cut thick metal because it cuts thick metal faster than plasma. Plasma cuts thin metal faster. So thick metal, and it has a superior quality cut in all those things that you're talking about than acetylene or any of the other fuel gases.
How does it compare with laser cutting?
Generally speaking, laser is good for thinner materials, and we're not in that market. Okay. But it's very comparable.
Okay, second question is, why does the flame not propagate back up the tube since you have premixed gases?
Good question. The flame propagates at a certain speed. In other words, it burns at a certain speed. And as long as the gases coming out of the torch are going out of the orifice faster than the flame is burning back to the orifice, you won't have an explosion back into the hose, what we call backfire. So when you shut the torch off, you have to shut it off quickly, or have a couple other techniques that we have. But that's how it keeps it from going back.
I'm from the coal fields in Ohio, and they've been a I hear a lot of requests for that they're hoping to get some kind of technique to heat that coal underground and just bring the gases out. Now, I heard you mention something about of all carbon fuels. They can do that if they had the right stuff to do it. I heard you say something about some metal that you did underground, you could separate it there. Have you ever give that any consideration of mixing that up, see what you do for burning carbon fuel underground, take the gases off and using it, and that keeps all the pollution down?
Yeah, I think what you're talking about is actually heating the coal so it gasifies itself. Correct. And that's like a wood gas kind of a technique. The Brown's gas itself as a flame won't do that, because if you put it against the coal, it burns it quite nicely, and all you end up with is carbon dioxide and water. So there's no advantage there. You don't have an actual fuel. If you heat the coal without the presence of oxygen, you end up with a lot of carbon monoxide and some hydrogen and maybe water vapors in that sort of a situation. Okay, one more question. Everybody's thinking it's time? Okay, nobody else wants to get up here. Thank you, Jerry. In a computer. Okay, welcome back. This is the Eagle Research Technology presentation part of the show. We're going to start with a little bit of slides. You put the slides in? Okay. Well, click. In the beginning, there's myself with my grandfather. He's reading me popular science in Wisconsin. This is me at age 11 in Oregon. This is where I actually started inventing things that I'd never seen before. I was a paper boy at the time, won a trip to Disneyland, did a lot of things. This whole presentation is going to go a lot faster than I originally designed it for. This is me after a hard day's work working on Brown's gas in the shop. This poor little kitten needed to be put to sleep, but you can see I went to sleep first. And this is me during that on the lake. And we're going to be going through what's called Eagle Research People here now. I'm the head of the company, and these are the various, this is a very slide on myself. Then we'll go on to my wife, Tanaj DaCosta. She's incredible. Actually got my life organized. Came from Toronto. I met her on the internet. And she's got some plans, big plans. Eagle Research isn't anything compared to what this is going to be. This is Joyce Mackay. She's our bean counter. And anybody that gets a video will be able to read this stuff a little later. I'm going through it rather quick. This is Mavis. She's incredible, and she's the one that fills the orders. Anybody that's making any orders, this is who it's going to be from. I actually had another picture that I wanted to put up where she actually had a phone on each ear. This is Art Davis, lab technician, learns quick, does his work well, and friendly, enthusiastic. It's great to see. Okay, what we're going to do now is a quick run of the video coverage that was missed yesterday because just a glitch in the recorder. It's going to be fast forward. It has to do with building the ER water torches. So go ahead with that as soon as you get a chance. Just go and fly at it. In the meantime, a little predate. The ER water torches, Eagle Research actually got into Brown's gas simply because I wanted, as an inventor, to be able to weld things together like plastic and titanium, which I'd heard that Brown's gas could do. which in fact that's still up in the air. I learned that there's a lot of myths out there on Brown's gas. Anytime you're ready. And this is the experimental jar, the actual museum piece that I keep. Okay, we'll go fast forward on this. This is a big Lincoln I was driving. And this is a Hyzor that I put in the back. We're talking water as fuel at this particular point. This is the power supply. This is what's on the dash that I was using to control it. You didn't have to have these kind of gauges, but I did. And then, of course, all the controls. Here's where, okay, stop, fast forward. And we're running an engine on water, lawnmower engine. I guess I should have asked for sound. In any case, the engine is running on water and then it pulls away. How quickly can we put sound in? And here I'm talking about the results of that. And here's Yoel Brown with his dynameter in Australia again. And a little bit more, and that's where he says, I really wasn't into welders. I really just wanted to power cars on water. And tells a little bit about how it was done. And then I start talking about a couple of other experiments where engines, internal combustion engines, are actually running on Brown's gas.
This motor is connected with the dynamometer.
A dynamometer, yeah.
Which dynamometer is measured the brake horsepower.
The brake horsepower.
That's right. The idea was how many kilowatt electrical energy is got there. How much...
Let's go ahead and fast forward. And here I have a Vega. You can pause for a second. I mean, not pause, excuse me, just come back to sound and regular speed.
The end of the torch, and then the tube goes down the barrel of the carburetor. No modifications on the engine whatsoever. This car has never even had a tune-up since the engine was rebuilt. The hose stuck right into the carburetor. We actually started this engine on the gas. The gasoline for the car has been turned off for a half an hour. It's at the back of the car. You'll see that the stuff coming out is simply water vapor. And if you, we're just getting water out the exhaust. There's actually water droplets in my hand here. Water. So.
I'm still live, folks.
It's just water vapor coming out the exhaust. Thank you very much for watching our video.
Right. Thank you. Okay. Now we'll go back to the slide presentation, please. And so this was the actual jar that I was doing. My original Brown's gas book 1 was written from the results I found in this particular jar. Came up with the theories of Brown's gas, which then I actually worked out the mathematics, and I figured on that particular Vega that I would require 3,000 liters an hour of gas production in order to idle the engine at 500 RPM with no load on the engine. And in fact, 3,000 liters an hour idled the engine at 475 RPM. So I figured I had the mathematics of the energy figured out fairly closely. Go ahead. Okay, click. Water is fuel. This is actually the book I wrote that compiled a lot of the different ways that you can actually use water as a fuel in an internal combustion engine. Since I wrote the book, more of the technologies have come to fruition or are coming more and more to fruition. Even this conference made a quantum leap in the, almost a logarithmic leap in the technology. So this is a very good book to start to understand all the different technologies out there to run engines on water. And this is where I should have been showing that videotape. And here we have the Hyzor technology. Now this particular book is one of those technologies that's mentioned in the water as fuel, and at this particular point this increases the efficiency of combustion somewhere between, depending on the engine, 5 and 50%. If you take all the suggestions that are in the Hyzor and the Super Gas Saver Secrets manuals, you'll generally get 50% increase in mileage even on fuel-injected vehicles. And this is that Lincoln again with its associated components. and it works on all vehicles. Unlike some of my other fuel savers, which worked only on carbureted vehicles or only on fuel-injected vehicles or only on gasoline or only on diesel, the Hyzor works on everything. The Carburetor Enhancer is a device that's required to put on any vehicle that has carburetor. You absolutely have to be able to control the fuel going out of the carburetor into the engine, not the fuel going into the carburetor, so that you can adjust how much fuel is going into the engine when you put extra vapor in. If you put a vapor carburetor or any kind of combustion enhancement device on a vehicle, you're getting extra fuel going into the engine, or you don't need as much fuel either way because of the combustion enhancement. So you have to be able to cut back on the fuel from the regular carburation system or fuel injection, so what this carburetor enhancer does is it cuts back on the fuel. Incidentally, the carburetor enhancer we discovered gives about a 25% gain on 75% of the vehicles all by itself. It became its own fuel saver as a spin-off. And there's a story behind that I can't tell at the moment, but it's all in the book. Then we'll go on and keep going to slides. You can put an oxygen sensor feedback into the system so that now you have the advantages of fuel injection in a carbureted system, and you can have deceleration fuel shutoff, and it's near zero pollution. I actually had hamsters living in the exhaust of vehicles that had carburetor enhancer and HYCO systems attached to them. The exhaust oxygen typically rises about 2%, which brings us to another one of our situations. When you put the HYCO 2A, and these are the parts that we have available for the HYCO 2A, it's a cold vapor evaporation system. And it requires the EFI if you're on fuel-injected vehicles. As I was talking about with the oxygen rising in the exhaust, the computer takes that extra oxygen and infers that the fuel mixture is lean and adds additional fuel to your vehicle. So what ends up happening is the vehicle loses mileage. We had a Saab that we put some magnetizers on, for example, and lost 15% in its mileage. We put the EFI device on it and gained 15% over the original mileage. So there's the kind of difference. The EFI helps fuel savers work. It's not a fuel saver. But if you have a fuel-injected vehicle and you put any kind of combustion enhancement on our technology or anybody else's, you have to have an EFI or a similar device. This is a HYCO 2DT. It's proven to, in independent testing in several countries, to prove 10% more power and decrease the fuel consumption by 10% at the same time. This is a huge bonus gain. The actual device in a production model is about $500 to put on a vehicle for parts and $500 for labor, and saves about $9,000 in the first year just in fuel cost on a large diesel engine. This is a HYCO 2DT, the actual mister ball inside that actually makes the mist, and of course the book explains what it's all about. These are the components in the commercial kit, and here's a installation on a VW, which actually got 40% increase in its mileage instead of 10 like on the large engines. Of course, VWs get pretty good mileage already, so you can imagine how happy that lady was. It also increased her power. Now, there's reasons why 200 miles per gallon is possible. I've already done it. I did it back in the late 80s. I got over 200 miles per gallon in a GMC pickup truck with a 292 engine. And the remains of that experiment are still around. There's a whole story behind that, which is also in my books. The first reason is thermal catalytic cracking. If you crack the fuel into methane, which is what we were doing, you actually gain about 10 times the fuel, 10 times the actual usable BTUs. And the reasons are in, if you get my flyer, the little yellow flyer that I have over on the desk over there, you can actually read about or get a hold of the information directly from our website, or just send it in by mail. The actual air-fuel ratio is a story I tell where if you actually take the measure what your RPMs are, and the distance you traveled, and the time you traveled, and the amount of fuel you actually used, you're going to find that 14.7 to 1 air-fuel ratio is a bunch of bunk. And most mechanics, even though they know this information and can do the math, don't do it. And I show how to do it, and in fact do it, and show that in most cases you're running already at a 36 to 1 ratio in an ordinary automobile, and when you apply the fuel savers, the kind of things that we do, 200 to 1 ratio is absolutely practical. The speed of combustion is something that's not considered when they do it. The only reason that gasoline engines even run is because of compression and speed of combustion. There's so little gasoline vapor going into the cylinders that if it wasn't for compression, there wouldn't be a dense enough air vapor fuel charge to even ignite, because gasoline can only ignite when it's in its vapor form and mixed with oxygen. When it's in its liquid form, it doesn't. So most of the fuel going through internal combustion engines is simply wasted because it doesn't burn fast enough at the right time to actually power the engine. It burns later, and they even burned it in catalytic converters, which is a heck of a pet peeve of mine. I'd rather burn the engine fuel in the engine instead of in the exhaust system. The capacitive thank you. The capacitive battery charger you can see over actually powering the experimental electrolyzer I have on the tabletop in a few minutes. It's the world's most efficient charger. Virtually every joule that comes from the wall actually charges the battery. It charges it in a pulse manner so that, similar to what Peter Lindemann was talking about before, you end up with a battery that charges faster than an inductive charger can. When it's set on 1 amp, it charges as fast as an inductive 4 amp charger charges a battery. And virtually all of the electricity that goes into the battery actually charges the battery. Yes, and the charger stays absolutely cool. There's no need for cooling fans or heat sinks or anything in it. It stays cold. This battery charger can recover sulfated batteries. It can charge many batteries at the same time. It just varies its voltage necessary. You put the batteries in series, so you have 2 volts, 6 volts, 12 volts, 24 volts all in series, and it just charges them all at the same time, which leads to a totally new kind of a battery charger you can have for electric automobiles. And since it's based on capacitors, you can actually put the capacitors right inside the vehicle in fenders anywhere in the vehicle and charge from any power source you just happen to run an extension cord to. You don't need these inductive charge things you see in popular science and the things they're experimenting with. It's very simple. It's easily home built, and there's absolutely no way that it can be UL approved. So the only way you're going to have one of these chargers is if you build it yourself. The reason is because when it's open, you can have 170 volts. If you plug it into 120, you can have 170 volts DC across the leads, and if it's limited to an amp, well, 170 volts at an amp is dangerous. Okay, we're talking Bill Beatty stuff here. So, and I expect people to actually use this thing. But I've used it for years, and a lot of other people have, and it's a very effective battery charger, but it works even better as a power supply. Okay, so all my ER water torches are powered with this capacitive power supply, which is then actually bolted right into the system, and there's no high voltage danger other than the regular just touching open leads inside a compartment. So next is we'll go directly into water torches in action, and what we're going to do is a quick fast forward on the building of the ER 1150 water torch that we missed yesterday. This is, when you go over to my table later and you start looking at things, you'll see this is the traditional, little plastic screw came off there. This is the traditional parallel plate electrolyzer that wastes so much electricity. This was typically running around with inductive power supply 6 watt-hours per liter of gas produced. This is an example of the first time I built a series cell electrolyzer, essentially the same metal plates, but this one produced like, it would be 10 times more gas and in the same volume of space kind of thing. So this is the basic thing that allowed me to build the water torches that you're going to see a little bit later. Okay, this is the first water torch I built. Go ahead and fast forward through this, yes. Okay. That was Rosie. This is a 2000. This is Kyle Schweitzer demonstrating the alpha version of the ER 1150 water torch, making lots of gas. This is AM Welding in Missoula, Montana, that did our initial what we're calling beta versions, production of the ER 1150 water torches. You can see the whole thing coming together. In a second here, you're going to see Brown's gas being used to actually make Brown's gas machines. You need a Brown's gas to make Brown's gas machine. These are liquid vapor separators that go on and help the mist, bubblers, shell. We've got run the torch this particular torch for hours and hours and hours, 24 hours at a time, for weeks at a time, as the machine gets assembled here. Then, once we got all the parts made in Missoula, we went up and actually assembled the machines in Canada because of cheap Canadian labor, see? And there we go. That's where we started from before. So we can shut that video off and we can go to the other video, torch video B, please. Okay, that was the quick version of building the ER 1150 water torches. So you could see that, and those particular machines were sold around the world. They gave us the credibility we needed when there's now a slight lessening in the crowd, and I believe I might even have enough of these brochures over at the desk after my talk so that anybody that wants one can come over and pick one up. I also have, for those people only please, I only have 30 copies at this particular moment. We're having a water torch meeting in November in Spokane, Washington, so anybody that figures they might be able to attend that meeting can pick up one of these flyers which explains a little bit more about it. And if you can't get one of these flyers because there isn't enough, you can simply go to the website, and it's on the website, this exact same page. So after the talk, you can go ahead and do that. Okay, go ahead. Sound, please.
Holes through the wood to give you an idea of the different characteristics of the flame, and then we'll go on from there. First, I'll light my torch, then Jim will light his torch. You can see the differences.
This is Jim Fleury, helped me a lot in the initial production. We're doing demonstration of acetylene. I'm operating an acetylene torch. I didn't turn on the oxygen first, so you can see a smoky flame. And then Jim Fleury lights the Brown's gas torch. These are exactly the same torch tips. And the because of the BTU contents, the Brown's gas...
The acetylene torch is quite loud, and the hydrogen torch makes very little sound at all.
The Brown's gas is only running at about 10% of the BTU.
It's almost 2 feet. The oxyacetylene is right close. Because they're both the same tip. Now we'll apply it to the wood.
Now you'll see that the acetylene flame will blow out at exactly the same time that the torch, the Brown's gas torch, goes through the wood. Acetylene requires about 30% of its actual burning oxygen to be from the air, therefore can't burn in an enclosed environment. Brown's gas will just keep burning as long as you can push the torch in.
You notice that the oxyacetylene could not burn through the 2x4. The laser-like Brown's gas flame went right through it.
I have this piece of metal over here so you can see the actual effects on the metal after.
Now we'll attempt or demonstrate going through a piece of steel.
Are you able to fast forward a bit? Okay, that's good.
Yeah.
What you're seeing is the acetylene flame.
The acetylene torch is just now starting to make a puddle. And I think we're going to call this off. You can see the oxyacetylene torch. Okay, we're going to pull the flames away. The oxyacetylene torch has made the steel hot in a large area. There's no red dot around where the hydrogen torch was, and it's approximately halfway through this 3/8 inch steel. We'll just compare the flames again. Same size tip.
This is very interesting. It shows the flame actually, the implosive nature, sucking in the smoke. This is going into a blind hole. The smoke that's created actually gets sucked right into the flame. You see that? It's a dirty piece of brick, so it smokes as being a hole being punched through it. But you can see that the smoke that's being created by the dirt is actually being sucked right into the flame. No other flame in the world does that.
So with ordinary welding techniques, ordinarily it's brazed. With this technique, we can just literally puddle weld it, just like Hubert's doing now. The metal flows on easily.
No flux of any kind.
Even easier than welding iron with oxyacetylene. It isn't done with cast iron, with any normal welding techniques. What we'll show is cooling it by dipping it in water.
I have this piece for you to see later.
Now we'll take this metal and dump it in water to cool it. As you can see, there was lots of heat involved there. And the weld is held, snapped off. It would here and a little weld here. This piece would have just snapped right off as soon as we put it in the water. The first time I saw that on video, I couldn't believe it. Weld copper with no flux whatsoever.
Notice I have a piece of tape on the torch, so the piece of tape does not melt. It's on there for demonstration purposes. Scotch tape.
Kiln ceramics, ceramics instantly. The higher temperature ceramics, it melts even faster.
It'll go through space shuttle ceramic just as fast as it went through that 5,000 degree ceramic. Welding aluminum just like that.
Just like that. Add a little in there. Real nice weld.
Notice how far away from the work I'm actually holding the torch. It has a very laser-like and pinpoint flame, and you can vary the amount of energy it actually enters the work by varying the way, how far away from the torch, how far away from the work you hold the torch. Here we're welding iron and brass and copper all together. Brass to copper.
What it does with different materials is, for example, heating iron. It takes a little while for the iron to heat, just about the same as if you were using an oxyacetylene torch. There we go. But for the iron oxide, it heats almost immediately. Is that
iron oxide takes about 10 times more energy to heat.
Brown's gas now to the flame. We have not turned on the oxygen yet, and we're not adding any oxygen to the flame. All the oxygen needed for the flame is coming from the water. And just because there's more flame doesn't mean it's any hotter. So now Hubert will turn on the oxygen, but only to the, for actually the cutting of the steel. One thing a millwright has to remember is to hold the torch higher off the steel than you do with normal oxyacetylene torch.
That's because the flame cones are longer.
One cut piece of steel. This particular torch is nearly silent. Just listen to it there a second. Now Hubert will light his torch. And you can hear how much louder it is. And now, well, one thing you generally wouldn't do with an oxyacetylene torch is hold on to the tip right close to the flame like this. What happens with an oxyacetylene torch, this is a piece of wax, is the tip gets hot enough that it's melting the wax. Can you see it melting the wax right onto the tip? Okay? The hydrogen torch does not get hot enough to melt the wax. The wax doesn't melt. I would not hold on to that torch. So we have a cold flame. We don't do that with that flame. Vaporize tungsten with oxyacetylene and hydrogen. Same size torch tip. Ready? apply just to a rock oxyacetylene and the hydrogen torch. 3, 2, 1.
We can fast forward.
The huge differences between using oxyacetylene and the Brown's gas torch on this rock that we just did. In this case, you could see it just ate right into the rock by almost a ½ inch. Just drilling right into the rock. Nice, different glassy surface. Over here is the oxyacetylene. It was just more or less doing some surface stuff, and it kind of made a foamy kind of the rock. It was flaking away the rock.
You see how much faster it took with the Brown's gas torch to punch a hole through the metal?
The flame is so hot. The hydrogen torch simply, the monatomic oxygen reacts with the ferrous material, causing it just to melt right straight through.
This was with no additional
totally
oxygen.
Different kind of an effect happening there.
Aluminum is much easier to weld with Brown's gas than oxyacetylene is because the Brown's gas tends to have its temperature more along the work that you're doing, whereas the oxyacetylene heats up all the metal, which makes it want to melt out a lot sooner.
Welding cast iron rod onto mild steel plate, just using a puddle welding technique. The advantage of welding dissimilar metals, like this is, they're both iron, but they have different carbon contents and stuff like that. This is a good advantage to weld dissimilar metals using a torch. Because it makes a very quiet shop operation.
I have this piece for you to see later. Using Brown's gas to make a spanner, kind of a wrench. An automatic torch cutting machine. Here we're just cutting a slice off some steel.
Fast it cuts per inch. Okay. So what do you think of that cut?
Now this was cut from torch tips that were using MAP gas. We just directly put the Brown's gas in. I have this piece of metal here too. What we did is this torch tip is made for cutting 1-inch steel with MAP gas. We stepped it. We started at 2 inches and went along and stepped it to 3 inches and then 4 inches. And at the point where it reached 3.5 inches, it quit cutting through. But you can see we did not vary the oxygen pressure. It just simply continued to use the same pressure. We slowed it down just a little bit as it went into the thicker material. And we just literally cut this piece of metal in half. And with a torch tip that would ordinarily have been a 1-inch, cutting for 1-inch iron, you'll see this piece of metal. It's absolutely straight all the way through. No cupping or beveling, none of that. All during this, the torch tips don't get hot. They have no slag sticking to them. There's no maintenance on the torch tips.
Oh, that had to do with how the other cut was.
Oh, okay.
And the flame was reacting.
So it distorted it.
That's the edge of the cut you just saw.
Absolutely smooth across there.
It was probably a little piece of impurity on the surface which caused that little trace down, but otherwise it's absolutely smooth. And that's it for that video. We've already seen this part of the video. Okay. And so now we are at, got about 10 minutes to go. We have a couple more things to talk about. Mostly I want to, is there video coverage for this up here? The, yeah, can you switch over? Okay. I'll talk about the, we're putting together a business of people that make money on Brown's gas, and we're having meetings on a fairly regular basis. The next one will be in November. I was talking about that before. So anybody that wants to find out how to make money with Brown's gas and join us, we can tell you where and when and all that kind of thing. The next one will be in November 17th and 18th in Spokane, Washington. Okay, and we're just about ready to start looking at samples here. And you'll see these samples over there later so you can get a closer hands-on feel of them. I'm not going to pass them around because we don't really have time. And I want to save a couple of minutes for questions. Okay, we're good? Can you see this? Okay, this is that piece of metal you just saw being cut. It's absolutely straight on both sides. The side we're looking at now is the side with the... Can you see that? It's smooth on this side here. It's absolutely straight. I'll show you some comparisons with other gases in a second. This over here is the virgin metal side, just as straight. Okay. That was cut with a 1-inch torch tip. If we had upped the oxygen pressure, it would have cut through the 4 inches as well. In fact, we did that later. This is where I took Brown's gas and cut off a thin sliver of steel. Ordinarily, if you go this thin, it would just melt off the edge of the steel. But Brown's gas flame doesn't heat the steel so much as acetylene or MAP or chemoline or propane or any of these other carbon-based fuels. So you can actually get very precision cuts. On this side, I don't know if you can see this bevel at the top. This is acetylene was cut off there. And then we cut a thin layer with the Brown's gas off on the other side. So the metal was already warm when we made that cut. This particular piece of metal is on what would be your left side, the acetylene, and on the right side is Brown's gas, 2 inches thick. And it's absolutely straight on the Brown's gas side. Okay, and this piece of metal is a MAP gas cut on the left-hand side, and you can see the slight cupping in here. Whereas the acetylene was showing a bevel at the top, the MAP gas is showing a little bit of a cupping. And you can see that the MAP gas cut is slightly rusty. And when you look at the Brown's gas cut, it's smooth, clean metal. And absolutely straight all the way down. So you get a superior quality cut, and it costs like a tenth the amount for the actual fuel costs. And you cut your oxygen by almost 40% as well. This is Brown's gas punching holes in steel. This is the actual splash that comes back out, and this on the other side is the laser-like holes that end up being in the steel. And of course you just punch through and then start cutting and make your tools or whatever you're going to do. This is welding copper. That's a copper welding you were just seeing with no flux of any kind. Just take a piece of copper rod, weld the copper together. Okay. You got that? All right. Okay. I'll turn it a little. Try to see the weld. Okay. It made a real nice smooth weld. This is the piece of mild steel and cast iron rod that was welded together, you just saw. And over here on the other, and you can see that where the Brown's gas was, it's still rust resistant. The weld is not rusted, even though the metal itself has. Now I'll turn it over, and you can see where I did another weld at another time, and I beat upon the weld, and the weld itself did not break, even though the cast iron did. This is a piece of aluminum pipe which I incidentally did some other stuff to, but this piece was welded together with by Hubert Hummel, that dark bearded man you just saw in the video. And what he was doing, it was the first time that he had ever welded, flame welded aluminum. Generally speaking, most welding these days is done with arc techniques of one kind or another. But this is the Brown's gas. We just cut a piece of aluminum in half, and then he welded it, and you can see inside the weld is absolutely perfect. It came through, but that's it. It didn't make any globs anywhere. He made it just about a perfect weld, and this was his very first attempt. And since then, I fooled around on the top of it a little bit and messed it up, but you can see how nice his original job was. Now this is an aluminum rod that has a flux core. But here's something very interesting. Ordinarily, you can't braze stainless steel, at least not very easily, and the Brown's gas allowed me to do a real nice braze on this stainless steel, just fooling around in the shop. This is that piece of cast iron that we cooled in water after we had welded it. You'll be able to take a good close look at it. When we cut these welds apart, we find that the structure, the crystal structure of the metal is virtually identical in the weld and the parent material. So that's one reason there's not so much stress. And the welds can cool fast without cracking. This is that piece of metal that was heated with acetylene here. You can see the big red dot that was formed. And then you can see how the Brown's gas was just cutting into the steel. This is why Brown's gas cuts steel so well and doesn't weld it very well. Welds just about everything else well, but not steel. But the very reason it cuts steel so much better than any other gas in the world is the same reason it doesn't weld steel well. So it cuts extremely well. And this is the oxide. This is not a Brown's gas cut. This was done with acetylene. But it had an oxide, ferrous oxide here, which then I was able to show that it actually heated the ferrous oxide faster than the original parent material. This is a characteristic of Brown's gas. You can almost think of it as an electrical flame, and as it puts the energy into the material, the higher resistance it has to heat, for example ceramics, the faster the Brown's gas actually heats it up, because the material can't get rid of the heat as fast as the energy is being pumped into its molecular level. This is an example of the hole that the acetylene makes. So you can see it's about 1 inch deep in the wood, and you can see that almost 1 inch diameter size of the hole. And if you compare that to a Brown's gas hole punching through wood, the actual Brown's gas punches through virtually any thickness of wood, and it does like a laser-like job. I can actually make finer holes in this too. I'm just using the same size torch tip for both of these. So anyone who knows their inverse square law can see that there's a whole lot less radiant energy from a Brown's gas flame than there is from a acetylene flame, as if there's any question after watching that video. Now we'll take a quick look at the, and you could turn that on now, if you would please. Whoever's at the capacitive battery charger over there, if you just flip the switch to the left. Okay, now over here we have the capacitive battery charger powering a small tabletop electrolyzer, which I call my clear cell. This electrolyzer has gone through years of testing of all different kinds and has been independently tested to be 98% efficient. In my lab, I can actually get much higher than that, as if you could get much higher than 98%. But this is just with clamps clamped to it, so we have heat losses in the connections and things like that. When it's actually fully assembled, we're talking extreme efficiencies. The capacitive battery charger on the left is being used as a capacitive power supply to make the Brown's gas in this clear cell. And it's just a series of plates and plastic spacers in a tube with electrolyte, which is 25% lye solution, and water. And you only ever refill with water. This particular electrolyzer has been running for about 7 years. They are so efficient that they don't heat up and they don't require any kind of cooling fan at all in my electrolyzers, of course, which reduces the amount of energy necessary to run them, and it makes them more efficient. So they only heat up, even the commercial-sized 4,000 liters only heat up to about 200 degrees Fahrenheit. And so now I have a couple of minutes for questions, and I'll retire over to the table, and people can pick up the brochures that they want while the next speaker comes on. Anybody wants to ask questions, just come on over to the the mic, please.
You said no flux on the welding, is that correct?
No flux for the copper and the cast iron. Okay. I used flux on the aluminum.
What type of rod did you use? Was it copper rod or?
Just a piece of copper, not even a copper rod. I just took a piece of copper electrical wire.
And the same thing for the...
And the cast iron rod you can just buy at the store, at the welding supply. Any other questions? We got a minute yet. Okay, I'll just show this. Okay, one more quick question here. Go ahead.
How come it doesn't corrode if you welded it? It's not on.
Not on.
This mic here, please.
There's a mic right here. Come on up. Steps.
How come it doesn't corrode after you welded it with the Brown's gas? Why does it resist corrosion?
Because it makes a super hard layer, oxidation layer on the metal. So the actual metal itself is already oxidized and sealed, so it doesn't corrode anymore. This is the actual, inside the clear cell, this is the actual plates, the small electrolyzer plates. It's just stainless steel, even iron will work. And then there's a plastic spacer, this is the shell, and then there's a plastic spacer, and then we put in the plate, and then another spacer and a plate and a spacer and a plate. There's no electrical connection between each of the plates except the electrolyte itself. So the electricity starts in at the negative side and goes through each plate and electrolyte in series until it goes out the positive side. So we end up with a high voltage yet low amperage, extremely efficient, makes a huge volume of gas, cool electrolyzer. Very efficient. Then to even make it more efficient, we'll use technology like you've been hearing about from Peter Lindemann and have super electrolysis. Thank you very much for coming.
I have a quick question.
One more question here, I guess.
Okay, thanks. I was just wondering if you recycled or reused the water in that Lincoln car that you modified. Or
No,
we just
went right out the exhaust.
Okay.
Yeah.
Okay, thanks.
Thank you.
That's it. Come on.